All right, so now continuing musings on trying to unify, or at least come up with a unified model for gravity and quantum field theory. At least what kind of mathematical tools there might be for doing that. And the most promising one seems to be the Clifford algebra, and specifically the space-time algebra. And we were talking about the pseudoscalar, which is a scalar quantity that squares to -1, just like the imaginary unit does. And then at the same time, it is a volume element with 3 dimensions of space and 1 of time, just like the general relativistic volume element. And so you put that in an exponential, and what do you get? It seems you get a sort of a phase space, and that phase space follows a symmetry, and it would seem that the symmetry is like that of the U1 symmetry in the Dirac field. So that what the calculations we do within quantum electrodynamics are not going to be threatened or invalidated based on this new theory. That will all stand, and that's a good thing because the experiments tell us it's correct. So having space-time curvature in terms of a phase space would suggest that space-time curvature does not necessarily have much effect on local aspects of the quantum fields. In other words, whether the interaction among quantum field elements, or the interactions of quantum fields, whether they are occurring here on Earth versus at the event horizon of a black hole, might not make a lot of difference. Now, of course, the paths, the world lines through space-time that the initial particles and the final particles, or states actually, will follow, that will very much be affected by space-time curvature. So it seems like we're getting somewhere. It seems like we can do quantum field theory in the background of a curved space-time. Now, I might be, there are lectures that I could watch about quantum mechanics on a curved space-time. I haven't watched those. Don't know yet whether that actually qualifies as a theory of everything. And I also haven't really investigated too deeply or worked out whether there really is such a thing as a graviton. I don't think gravitons are going to end up being inner or interior lines of Feynman diagrams. I think they're going to have a different function. It isn't like the gravitational force will be exchanged between two particles on world lines, like the photon is, or like other bosons are. So what role does the graviton play? I suspect it's going to have something to do with the boundaries of where certain particles exist and where they don't. I think it's also going to have to do with the way that nature, and in fact the consciousness of the universe, naturally collapses a quantum mechanical wave function. So, all right, way more to come on that, as always. All right, that's good for today.